Well, here's a page lecture for you, and I'll glance to the right so I can look at my notes. Light energy, that is energy of colorful mysteries. Now that's kind of a provocative title. What you see on this page is a pretty standard depiction of electromagnetic energy. That's a spectrum of energy that's mysterious because we really can't figure out how it can be acting both as particles and as waves. Particles you might think of as little dots or little points of something that stream from, for example, the sun to the earth. And we might call those things photons. Well, that's one way of thinking about them because sometimes they do act like particles. On the other hand, they act like waves at various times, waves that are actual pulses of variation in pressure or energy. And how they can act both ways is one of the things that Einstein took a look at in his theory of relativity, and it gets into quantum physics way beyond what we talk about in this course. However, if you take a look at the chart on this page, and by the way, the chart appears in black and white in the print edition of this workbook, but when you look at the same illustration using the QR code on one of your mobile devices, or you follow that URL to see this image on a computer screen, of course you'll see it in full color. And that's one of the advantages of this form of workbook. It can be printed cheaply, black and white. We don't have to worry about color printing anymore because it's taken for granted in this online course that you have a computer or a mobile device of some type to access the web, and of course your screen will be in color. And that's how you'll perceive the color of the chart that's on this page. Now what the chart is showing you is that electromagnetic energy, as it streams from the sun or other celestial bodies, covers a wide spectrum of frequency. That is the vibration rate of the energy acting as a wave. It's only a very narrow portion of the spectrum that we call visible energy. The visible spectrum is where we see light. That's because our eyes are sensitive to that form of energy. We're not sensitive to energies that are either lower or higher in frequency than this. Lower in frequency, you can see immediately to the right of the visible band of energy is infrared. We can feel that as heat, but we can't sense it with our eyes. We need special kinds of instruments, for example, goggles where you see at night by having the countryside illuminated with infrared radiation. Eyes can't see that, but detectors can pick it up and render it into some form of visible energy we can see. So infrared cameras can do that. The point obviously being that whoever is out there can't detect that they're under a field of illumination of infrared radiation because their eyes can't see it either. On the high end, that is above the visible spectrum, we have ultraviolet and we have X-rays and gamma rays. These are very high energy wavelengths or particles, if we choose to refer to them that way. Most of the time they can do damage to our bodies by damaging the DNA that your cells contain as a pattern for replication. So cancer is associated with a lot of exposure to these higher energy rays. Your eyes can't detect them either. What our eyes do is kind of magic. Within that narrow band of electromagnetic energy, our eyes have various kinds of cells in them that can detect some of those frequencies of energy. And you'll learn later on in this course that your eye is made up of sensors for red, green, and blue to measure the intensity of the energy of those colors, that is, of those frequencies, falling upon them. And those signals are sent separately by the optic nerve to the brain, and the brain integrates those signals and forms what we see. That is, the images we see, the objects and their shape, but also their color. Later on, we're going to talk about why objects have color. We've started to talk about that subject on the prior page, and that is with the little cartoon that shows you that electromagnetic energy from the sun, which illuminates the things that we're going to be looking at, contains all these frequencies. Some of the objects that we see don't reflect all of those frequencies. They absorb some of them. What they reflect is what we see the object as having that color. Your eyes receive what's been reflected, and your brain turns that into a sensation in your head that is the color that you're seeing. So with that in mind, take a look now at the next page, which talks about the temperature of light. That has to do with the mixture of the frequencies of energy that are in the light by which an object is illuminated.